Hello, everyone. My name is Connor Johnson, and I'm a MakeMo, or Mobile Makerspace Librarian with LA County Library, and I welcome you to How the Internet Works. Before we get going with today's event, I'd like to take care of some housekeeping. If you can hear me and see the slide on your screen, then you're good to go. However, if you're having trouble hearing me or seeing me or the slide, do let me know in the chat, and I'll do my best to assist. If you'd like to listen to this presentation on the phone, you can do that by calling 1-669-900-6833 and using the access code 812-7724-7497 and passcode 123123. You may have noticed that the mics and video are disabled for attendees. This is so everyone can focus on our presenter. We do, however, welcome your questions and comments. Questions should go into the Q&A box and comments can go in the chat. Before we begin, I'd like to tell you about our next event in 2 weeks, Intro to Photo Editing, on Thursday, July 27th at 11 a.m. Turn your everyday snapshots into works of art. Handy editing functions such as crop, rotate, adjusting exposure, sharpening an image, and adding filters and text can be essential tools for turning an ordinary photo into a masterpiece for adults. I'll post that in the chat right now. Go ahead and register. It's free as are all library programs. If you'd like to learn more about our virtual or in-person events, head over to lacountylibrary.org and click the events link at the upper right-hand side. Okay, now with that out of the way, let's go on to today's event. Today's presenter is Lawrence Mack, also a MakeMo librarian. On any day of the week, he can be found throughout LA County presenting STEAM or science, technology, engineering, art, and math programming at schools, library branches, and community centers. Lawrence, the stage is yours.
All right, thank you so much for the introduction, Connor, and good morning, everyone. Please hang on just a second while I share my presentation, and we will be on our way. Okay, so welcome to How the Internet Works. In today's program, we'll cover a bit about how the internet works, including a brief history, simplified version of what actually goes on when data is being transferred, and also some popular topics that you might not have heard about or that you have heard about and are curious about, such as like Web 3.0 and the Metaverse. Again, if you have any questions during the program, please feel free to let us know in the chat on the right-hand side of the screen, or actually near the, let us know in the chat or the Q&A, and we'll attempt to address them at the end when we have our Q&A session. For more library news, including upcoming programs, resources, and events, visit us at lacountylibrary.org, and we're on all the major social media platforms, such as Facebook, Twitter, Instagram, and more at LA County Library. So be sure to check us out there. Now, let's get started. Okay, so have you ever wondered how the internet works? Get an overview of the history of the internet and our increasingly interconnected world. And we'll also discuss the roles that people like you and me can play within the digital space and touch on some interesting developments such as Web3, the Internet of Things, and the Metaverse. So first off, what is the internet? It's a pretty all-encompassing nebulous term, but one of the definitions that can encapsulate all that is from Britannica, and that's a system architecture that has revolutionized communications and commerce by allowing various computer networks around the world to interconnect. So it's also described as a network of networks. And basically what a network is, it's just a bunch of connected devices. So a bunch of connected computers, or if it's a human network, it's a bunch of connected people. So it's a network of networks. And to kind of put that into visualization, there's the image there of all the little pieces, and there are lines interconnecting all of those game pieces. Now, what's on this network? Well, there are a lot of websites that are hosted on these networks that you and I access, and we access those through our computing devices, whether that's a PC, Mac, whether it's a tablet or a smartphone, and we access them through browsers. So browsers are software, for example, Chrome or Safari, and those are used to access these websites on the internet. So it's a global network of billions of computers and other electronic devices. And what you can do with the internet, you can access almost any information, and you can communicate with almost anybody else in the world. But the internet was not always such a big place, as we'll find out with the internet's beginnings. So the internet kind of started with something called ARPANET. In full, it's the Advanced Research Projects Agency Network. Pretty big mouthful. But it was an experimental computer network that was the forerunner of the internet, and it started around 1969. And it was developed by the Department of Defense through the ARPA agency, which is the Advanced Research Projects Agency. That's an arm of the US Defense Department. And they funded the development of this ARPANET in the late 60s. Their goals were to share access to research, computers, and improve military capacity. And as you can see, the network, you can see how the ARPANET was created in all the way in 1984. So as you can see, it's mostly the East and West Coast being heavily linked to each other, and there are a couple sites in the Midwest. But most of these linked devices, most of these linked computers were at large research universities. And they were able to share research, pool their knowledge, and work on military stuff. Let's see. And then next, we get the TCP/IP, or something called the Internet Protocol Suite. You might have heard those acronyms bandied about. TCP/IP, which stands for Transmission Control Protocol and Internet Protocol. It's a framework for how the internet communicates. It helped to standardize how data was sent and received over the internet by providing specifications on how data should be packetized or broken down into manageable chunks, how it was transmitted, routed, and received. And it's the backbone of how internet communications works. And we will cover TCP/IP in a little more detail in just a bit. Okay, so after ARPANET and TCP/IP, kind of move on to NSFNET. So this is in 1986, the National Science Foundation took the development of the internet to the next level by funding NSFNET. And this was a network of supercomputers throughout the country. These supercomputers laid the groundwork for personal computing, bridging the gap between computers being used exclusively for academic and military purposes to computers being used to perform daily, everyday tasks. And at this point, they're beginning to loosen restrictions on who can use the internet, and the widespread adoption is sort of beginning at this point in time. And it laid the foundations for our 56K network, so dial-up internet. If you've had the privilege of using dial-up internet back in the day, where if you turned it on, then you couldn't use your landline, then you'll know what I'm talking about when it's connecting and then you hear You hear it dialing and all these beeps and clicks. That's our 56K network. In the early 1990s, all commercial use limitations disappeared. So that allowed the rapid growth and diversification of internet service providers. So, you had different internet service providers like AOL, like Earthlink or Net Zero. A lot of those popped up, allowing you and I to purchase an internet subscription and be able to log on and use the internet. Okay, so, and then now we move on to how the internet works. So in a nutshell, it's a network that transmits data across interconnected devices. And data sent is called a message. And the messages are broken up into tiny parts called packets. And they do that because it's faster to send data broken down into tiny bits across the internet than it is to just send that whole file on its own across the internet. Because, for example, if one source of the data routing shuts down, those tiny packets, a lot of them can be rerouted through another clear pathway to the receiving device. However, if you're just sending one file, one big piece of data, if whatever path it's going through is suddenly blocked, then that whole file would be blocked. And then that person, whoever's sending it, would have to resend it again. Now, if you break it down into tiny packets, it's much more efficient. And even if one route is blocked, there isn't a lot of data lost if the other packets are rerouted to the receiving device. So you can kind of think of the internet like a virtual postal service, but on a much, much greater scale and speed, if you think of each packet as a letter. All right, and then more on TCP IP protocol. So first, the TCP. TCP stands for Transport Control Protocol. And what it does is it helps ensure the transfer of data is reliable. All right, and then next we get to IP, which is the Internet Protocol. And that specifies how information should be sent between computers with numerical addresses. And if you've ever heard the term IP address, that's the numerical address that's being referred to here. So each device that's connected to the internet has its own specific IP address, which allows other computers on the network to identify that computer when it wants to send a file to that specific computer. Okay, so think of the IP address as just basically the street address for your computing device. Okay, now, so here's also very brief overview of how data is actually sent. So first, your device is connected to the internet or the web through a router or modem. So a router is basically a device that allows multiple computers to join the same network. So a router would be like the wireless router that you might have in your home. So what that is, it broadcasts a local network that allows all your devices with Wi-Fi to connect to that router. Okay, and what a modem is it's a device that allows you to connect to your internet service provider, whether that's, for example, Verizon or AT&T or Spectrum or Frontier. That's an internet service provider that is basically a company, a service that provides people with access to the internet. Now, routers and modems, these work in combination and are frequently found as a combination device that these internet service providers like Spectrum or Frontier, that they provide you with when you sign up for their service. Okay, so first, your device is connected to the web through a router or modem. And when you're connected and you start browsing the web, let's say you go on to Google to look for something. When you go onto Google, um, or if you click on a link um, on a Google search results, then that request for information is sent and processed by your ISP or internet service provider. All right. And the request is then sent to the target server. So the request is then sent to the machine that's hosting the website with information that you want to send a copy of that web page back to your device using TCP/IP protocols. And so once they send that copy of the web page to your device, then the web page will load on the browser that you're using. So if you're doing all this through Chrome, then your web page loads through Chrome. So basically, if you have a look at the diagram on the right, what we see is pretty much the top, the network topology. When host A, which is, for example, yourself, sending a request to host B, which is the computer that hosts the website that you want to visit, for example, like Google or Wikipedia. And so that's kind of the instantaneous transmission of information that we see. However, the data is actually routed through a much more complicated process, as you can see in the data flow chart below the network topology chart. So basically, it's involved in multiple layers where the application starts communicating through multiple hosts, and it's routed through different networks to actually reach the website host, and then for it to send the information back through different channels as well. So there's a lot more going on under the hood, but fortunately, we don't need to fully understand how it works in order to enjoy the results. All right, so now you know a bit about how the internet works. So the next part of our program will focus on some popular buzzwords that are popping up, that have been popping up, for example, over the news or over social media that you might have heard about. I kind of chose them because they're sort of exciting new developments that may not be too clearly explained. So I just want to try to clarify them so you have at least a concept of what they represent. And once you have that concept of what it represents, it'll be much easier for you to research that topic and to find out more once you get a couple starter points. So what I want to focus on first is something called Web 3.0. And you might have heard that phrase, Web 3.0 or Web 3, bandied about. And it's a descriptive term that envisions the evolution of the web to incorporate something called decentralization through technologies such as blockchain. Now, I kind of want to explain what Web 1.0 and what Web 2.0 are first, so that you can build upon those foundations to reach where they're now describing Web 3.0. Okay, so first, Web 1.0, and that's basically the start of commercialized web browsing. So maybe from 1990 to about 2004, most websites were static, which meant that very little changed on those websites. It basically had information. People were consumers of the website. There was no real interactivity. There's no real input that people could submit on the website and that could see changed. All right, so here's sort of a Web 1.0 page. So this is like a screenshot of Apple's web page from way back in the day. As you can see, so you can kind of see what Web 1.0 pages are like, because the graphics are very basic, and it doesn't look as streamlined or user-friendly as a lot of websites look today. Okay, but the most important thing is Web 1.0 sites are static. So they contain information that might be useful. But once you read that information on a site, there's no real reason to return to the site later. So, so this example is a personal web page that kind of gives information about the site, but it doesn't really change. You know, there's links and there's things like that, but you can't really interact with it. And that's another thing about Web 1.0 sites. They aren't interactive. So you can only visit those sites. You can't really impact or contribute to the sites. All right. So that's a Web 1.0 page, just basically as information. You can't really interact with it. Now, from about 2004 to now, we're in what's called Web 2.0. And that's with dynamic websites where users can consume and produce a lot of content. So for example, social media sites. Social media sites, things change very frequently. So there's new posts happening all the time. You can interact with a post. You can like posts. You can reply to posts. You can post your own stuff. You know, there's YouTube where you can consume video and you can comment and like and subscribe to different channels and different videos as well. And of course, there's also something like Wikipedia. So this is a real Web 2.0. So this is a Web 2.0 web page. With Wikipedia, it relies entirely on user submissions and user changes to keep its information updated and accurate. So this is kind of like the ultimate interactivity where almost anyone can create an account and start editing and submitting their edits, and potentially you know, change entirely how an article is written or cited. Okay, so interactivity is a big part of it, and then also something like Amazon. So Amazon, for each product page, there's lots of user reviews, so you can go and interact with those reviews. You can mark them as helpful or unhelpful, and you can also submit your own reviews. So that's all part of the Web 2.0 philosophy. Web pages that you and I can impact and change. All right. And so that gets, and so Web 2 is pretty cool, but there have been concerns about large corporations, big tech, that monopolize Web 2. So a lot of these big tech corporations, whether it's Amazon or Facebook or Google, Microsoft, they're becoming major players on the internet, and they're controlling large portions of the internet. And they're also mining your data to sell, to make money. So a lot of what's leading to this new Web 3.0 talk are basically concerns about the monopoly that big tech holds and the centralization of internet assets and the need to protect people's privacy. And that kind of leads to Web 3.0 talk. So Web 3.0, it focuses on decentralization, mainly in the form of control and ownership of virtual assets, moving from centralized institutions, which is basically the big tech like Facebook or Google or Microsoft or Amazon, moving from centralized institutions to users like you and I. And so a big part of making the new Web3 basically incorporating elements of things called blockchain or things called cryptocurrency. So basically, it's all about decentralization So cryptocurrency proponents like it because transactions can be done directly without the oversight of big financial institutions like banks. It can just be a transaction between two users. And then also there's things called NFTs or non-fungible tokens. That's a unit of data that's stored on a blockchain, which is a form of digital ledger. And that ties into the whole decentralization and ownership, whether it's partial or whole, of virtual assets in the form of these NFTs or tokens. So these NFTs can be associated with, for example, digital files, such as like photos, videos, and audio, or other types of virtual assets, such as like a digital space. And so their whole concept of ownership is that because each token is uniquely identifiable, the holder of that token can be recognized as the legitimate owner of that virtual asset. So like a proof of ownership, a receipt of ownership. And basically Web 3.0 is focused on the accessing and utilization of the internet without the control and oversight of big corporations and companies, basically eliminating the middle. Okay, so moving on from Web 3.0, there's also something called the Internet of Things, or IoT, and that describes the network of physical objects, or the things, that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. So kind of a cool visualization of the Internet of Things in the graphic, as you can see there. Not just computers being connected to each other, but things like printers, or even cameras, or lights, tools, planes, a lot of different things. If they have sensors and internet connections embedded with them, they can communicate with each other. And a whole industry has sprung up with a focus on filling our homes, businesses, and offices with these IoT, or Internet of Things devices. So these smart objects, they can automatically transmit data to and from whatever company they're from. And these invisible computing devices, they help collect data, which benefits analytics to help improve products and services. Another side effect is they collect the data for analytics and to sell for money. But some of these products actually do help improve our lives through automation. So for example, if you have a smart device, like a refrigerator that's connected to the internet, if it's a particularly hot day and you're away from your home, but you know that there's something perishable in the refrigerator, you can just on your phone connect through an app and have it automatically make the temperature cooler. And then going on a similar vein, if your garage door opener is connected to the internet, you can open it while you're you can open it before you come into view of it while you're on the road. Or even if your AC system is connected to the internet, you can immediately see before you get home how hot or cold it is and adjust the temperature accordingly, so that when you get home, it's already pre-cooled or preheated for you. So that's some of the ways that they can help improve our lives through automation. However, there are some privacy concerns, especially with devices that have cameras and microphones integrated within them. For example, your cell phone or your tablet. If there's hacking or if there's data leaks, that might compromise a person's privacy. Now, a lot of these devices range from ordinary household objects to sophisticated industrial tools. There are more than 7 billion connected Internet of Things devices today. But from a report I saw, they're expecting this number to grow to more than 22 billion Internet of Things devices by 2025. If you think about all the devices and gadgets that you buy that have an internet connection, more and more are having that. An example would be like a smart TV. Nowadays, it's very hard to find a TV without an internet connection. The vast majority are connected via Wi-Fi. So that's one of the things that's focusing exclusively on being a connected device. Okay, and then here are some more examples of things that can be considered part of the Internet of Things. So there's a smartwatch. Like, for example, if you have an Apple Watch, then that's part of it, because in addition to having like a microphone for you to talk with somebody, it also has different sensors, like, for example, your heart rate or your steps and things like that, that it incorporates, and then it can transmit that data to your apps. Another thing is a smart car, like a Tesla. So there are many ways vehicles, such as like this Tesla, can be connected to the internet. It's got a lot of cameras. It's got an infotainment system, and they collect data from a lot of things, like the accelerator, the brakes, the speedometer, the odometer, and they use all that to monitor both the driver performance and vehicle health. So there are lots of benefits to these things. Like, for example, rental car fleets can monitor how the car is being used, to help parents track the driving behavior of their children if their children are underage. They can notify emergency services automatically in case of an accident. And also, they can help predict and prevent vehicle maintenance needs. Like if the check engine light is on, if it's a connected vehicle, it might be able to shed more light on what exactly is the problem rather than just having the check engine light on. And then there's smart cities. That's kind of a concept on the horizon. So Internet of Things applications have made things like urban planning and infrastructure maintenance more efficient. So like governments are using these applications to tackle a lot of problems in like infrastructure, health, or the environment. For example, connected devices can help streamline, for example, measuring air quality or radiation levels, using smart lighting systems to help reduce energy bills, and detecting maintenance needs for critical infrastructure, like for streets, bridges, and pipelines. For example, I think I heard through the news that that California is using autonomous cameras mounted throughout the state to help detect wildfires early. So basically, they have these sensors that can help detect if there's a wildfire, and then direct personnel there to hopefully get it under control. Okay, and then finally we come to the metaverse. So the metaverse is kind of a concept of a virtual world that's focused on social connection that's parallel to our own. What it basically is, the metaverse refers to like a shared online spaces for people to work and play. And right now it's a very nebulous concept. It's not entirely too well defined. It's very basic. But in the future, they might be able to make more immersive experiences with virtual and augmented reality. Like, for example, with the virtual headset that you see this person using. And then the concept of metaverse also coincides with Web 3.0, the concept of owning digital property, such as like land or houses through NFTs on these shared online spaces. But that's basically what it is at this point. There isn't really like a killer app or anything too concrete with the metaverse, but that's basically what it is. But keep an eye on it. there might be more interesting developments in the future. All right, so how can you get involved with the internet more than you already are? Well, obviously there's the consumer part. So you can consume internet content. You're surfing the web, you're watching a video, you're part of the audience on this digital literacy program. So what we do, if you use the internet, you're probably already a consumer of internet content. But what you can do, that Web 2.0 is all about, is to produce or to contribute your own content. So you can do that by creating your own video and uploading it to, for example, YouTube or Instagram or Facebook. You can create a photo gallery and post that up, especially on social media. You can tweet or blog, blog your thoughts, blog your opinion, or you can design your own website and create your own space on the internet through the use of HTML coding. So there's lots of different ways to get involved. And the best part about the internet is there's almost limitless potential to get involved and to consume. So again, just have fun exploring. All right, and to learn more about the concepts that we discussed today, we have a great catalog of actual books and ebooks and audiobooks and more. As you can see, some examples about the Internet of Things, but you can also learn more about the Metaverse, about Web 3.0 and other concepts just by looking through our catalog. You can also learn more about the internet through our online learning platforms, through LinkedIn Learning, Gale courses, and also through more programming, such as the digital literacy programming that we do every month. And if you have any questions at all about any of the topics we discussed here or about anything in general, feel free to speak to a librarian. You can reach us over phone, text, email, or instant librarian, or you can visit any library, visit the reference desk, and we'll be happy to help you with your question. All right, and that's the presentation. Thank you so much for attending, and let's move on to the Q&A.
Great. Thank you so much, Lawrence, for that exciting and informative look at how the internet works. We will be going on to the Q&A portion of our talk today. So if you do have any questions, please put that in the Q&A and we will get to it. We do have a few questions to start off with. So we'll just head into it right now. The first one we have here, Lawrence, could we address generative AI, ChatGPT, and how we can use the proper language to utilize this tool?
Oh gosh. Well, I haven't used generative AI that much, but Connor, I believe you did you did something
Yeah,
recently
we
on
just did
this. You might be better
a big
equipped to handle
presentation.
this.
Yeah, on AI. I'm hoping maybe the person that asked could, if they're able to clarify a little bit. So addressing ChatGPT, how we can use a proper language to utilize this tool. I want to make sure I'm answering it correctly. So we'll come back to that unless maybe we get some a follow-up. I want to be able to answer it how it was meant. So let me skip that one for right now. And Lawrence, here's one that you've done a presentation on separately, and this is, would you describe blockchain?
Okay. Okay, so a blockchain, you can think of it as a database or an online ledger that's shared among several computers. So what it is, it's an online database that stores data, but it stores data in something called blocks, in blocks of data. All right. And blockchains can be made immutable, which means that the data that they store cannot be altered or changed. Because there's no way to change a block, that means the only trust needed is when the data is entered. And since it's shared among a lot of different computers, the data can be verified rather quickly. Whether when somebody makes a claim, the data can be verified rather quickly. Okay, so basically it's decentralized so that no single person or group has control. Instead, instead, all users should collectively retain control of the blockchain. All right, and that's sort of tied into cryptocurrency. So basically, just think of blockchain as a digital database that stores information and is distributed among a lot of different computers. So no one computer controls can control the entire blockchain. Okay, and so for example, cryptocurrency or Bitcoin, it's tied to this because because all of the transactions of, for example, Bitcoin, they're stored on the Bitcoin blockchain so that it can all be tracked. And so all the transactions can be tracked and people can see where it's been sent, like to which machine, to which wallet that it's been sent. So that's sort of the very bare bones definition of a blockchain. Is an online database that can record data and that cannot be changed.
Cool. Great. Thank you, Lawrence. And I think we got some clarification for the first question. So let's go back to that really quick. So I think they're looking for how to use language to make the generative AI like ChatGPT the most productive. And I think I would answer that in with the generative AI, and you can ask a prompt, put in a prompt, and get a response back. I mean, the technology has gotten pretty it's smart enough that the input that you ask it, or the prompt, does matter. But usually can suss out what you're asking, and if the responses that you're not getting, that you're getting, aren't what you're looking for, you can try to ask it in different ways. It is so kind of difficult to answer without a concrete example. But being able to ask it, and of course being aware that we did talk about this in the AI talk, that these aren't always factual answers that are getting taken back to us. The technology is still improving and emerging. So when it does come to AI and asking and giving a prompt to get a response back, you still have to be the human that looks it over, and marks off whether these are factual responses or not. It does make things up sometimes. So that's the most important language that I would say would need to be under there, and understanding that you're not going to automatically get everything 100% proof, verified, factual information. So to be the most productive, type in your input, get your response, but then don't take it at its word either. And it just is going to also depend on the stakes. Like we were looking at, camping lists, is going to be different than asking like a wall, like a Wall Street question. I'm just gotta get my light back on in my room. So if that kind of answers the question, if not, maybe send another, and I can give it a different response. But let's move on from that question, because we've got a lot more that came in. And I want to get to those. So the first one, please define HTML.
Okay, so HTML is what's known as hypertext markup language. So it's basically the code that's used to create web pages. And you can definitely learn HTML coding. There's classes on our online learning platforms like LinkedIn Learning or Gale Courses. And there's lots of resources on the web to learn about it as well.
Great. Thank you, Lawrence. And now I know you kind of talked about this, but maybe you could state again, how does the information move on the internet technically?
Well, think of it as moving in little packets of data. So the data at its most basic is broken up into binary code, which is basically combinations of ones and zeros that, when put together, form something larger. Lets a computer decipher it as to be something larger and more complex. Now, what the packets are, there's basically small bits of ones and zeros that are sent along the network. So they're sent so you can think of it as moving from machine to machine, and that information is transmitted from one machine to another. And that's what it pretty much is. Little bits of ones and zeros moving from one machine to another. And they pass through a lot of different machines or networks in order to reach their destination.
Cool. All right. Next question we have is, what is the dark web?
Okay. So the dark web is basically a hidden collective of websites. So these are websites that will not show up on your Google search. They won't show up on any search engine because they're hidden, and they can only be accessed by a specialized web browser. It's something called Tor browser, Tor, and it's estimated that the websites that do appear on search engines are only about 10% of the actual internet, and that most of it is hidden sites. And these sites are used for a variety of things. They can be just for keeping internet activity anonymous, private, which can be helpful both legally and illegally. Some of it's used to evade, like, for example, government oversight. But some parts of the dark web are known for illegal activity as well. So yeah, that's what the dark web is. Like, that's sort of an explore at your own risk type of deal.
Yeah. Very good. All right, now please give examples of virtual assets and digital assets. How are these controlled by the owner?
Okay. All right. So if you've heard of something called NFTs, or non-fungible tokens, that's a type of virtual asset. If you've heard of something called the Bored Ape Yacht Club, okay. And what it pretty much is, it's a cool picture of something like an ape. I think it's better if I show you, because yeah. So give me 1 second.
Sure.
I'm gonna show. Okay, I'm gonna share my screen. All right, Firefox. Okay, so something like Bored Ape Yacht Club, and we're going to take a look at the images. Okay, so one of these would be an example of an NFT. They're one of the more popular ones, and at its core, it's basically an image file, like a JPEG or a PNG or something like that. But it also comes with a small digital token that verifies. The digital token is recorded on the blockchain. So it verifies that you, or whoever possesses that token, is the owner of this digital asset. Okay, so it's basically like a receipt for digital ownership rights. And yes, people can just make a copy of this image file. Like, for example, I can just copy and paste this, and I can use it for whatever I want. So technically, it's anybody can use it, but um, that token will say that you are the owner of this asset. So it's kind of like if you think about knockoffs and the original product, you can kind of think of it in those terms. Like there can be imitation products, so that's if I copy and paste this, then that's an imitation. But the original that can be verified with ownership is with whoever holds that NFT. That's that's I think best way to describe it.
Yeah, no, it's kind of a confusing concept. When you kind of mention, you kind of own the receipt, and the token is saying yes, you own it, but anybody could have that in their possession, but not necessarily own the token that says they actually own that digital asset. Interesting stuff. We'll see what continues to evolve in that field. But thank you, Lawrence. Let's see our next question. What are the best ways to protect our privacy on the internet and on the Internet of Things?
Wow, that's a pretty expansive question there. Well, to protect your privacy on the internet, the first rule is don't share things that you wouldn't feel comfortable sharing to somebody else in the room with you. Okay, so don't share your personal information, don't share your social security, um, your credit card numbers, bank account numbers. Don't share those that you wouldn't share with a stranger on the street. All right. And on the Internet of Things, if you have connected devices, you want to make sure that camera and microphone access are limited to certain apps, or you just want to restrict access altogether. It depends on what type of device you have, to be honest. Like if you have a Tesla, there's probably so many devices on that vehicle that are transmitting data, it would be very hard to limit privacy for something like that. So yeah, just use your common sense and don't share things that you wouldn't share with strangers. Connor, do you have anything to add to that?
No, that's definitely the first rule, sure. And Yeah, I mean, you can always take advantage of two-factor authentication if that's an option. That's where you might get be able to log into something using your phone, as opposed to or in addition to a password. Using a password manager, not using the same password. Yeah, a lot of little things that do add up to security, but start with by not sharing anything more than you have to, and then for the sites that you do visit, use a variety of passwords, multi-factor authentication if it's available. But yeah, good questions, because we all have stuff we want to keep private that we might put out on the internet. Got a lot more questions coming in too. So I'm not sure. Can you explain how Wi-Fi works?
Okay. So this is the router and modem part of the program. So your Wi-Fi router, it basically broadcasts a local network for your devices to connect to. So if you're in range of the device and you have the password, then your device connects to that router, which will then connect to a modem. And that modem allows you to connect to your ISP, your internet service provider, whether that's like Verizon or Spectrum or Frontier or any number of internet providers. And then they give you access to the internet. So the Wi-Fi pretty much has a local network that allows you to wirelessly connect with your devices if you're in range.
Great. We have define browsing incognito.
Okay, so that's a mode that a lot of web browsers have. And that's more privacy-focused browsing. So what they usually do, if you browse incognito, it will not save the history. It will not save the browsing history during the time that you browsed incognito. And it will not save any cookies during that time that you browsed incognito. However, any files that you download, like if you downloaded like a music file or a PDF or something like that, those will stay. All right. So anything that you anything that you expressively download will stay. But your browsing history and browsing cookies and browsing data for that session will be deleted.
Great. And here is how do you create an NFT?
So that's outside the scope
Yeah,
of this
I'm like,
program.
I'm not sure.
You would need to work on the blockchain that you want the NFT to be on. And so you would need to code on that blockchain. All right. And that's pretty much that's pretty much the extent of the answer. But you can always just do a search for how to create an NFT. And there should be a lot more pointers on either YouTube or just Google.
Great. Now this one I might have to type into Google if I answer. So define the term cache.
Cache.
You know, as used you know, with the internet. I think when when data is cached, I think that they might be
Okay.
referring to, yes, CACHE.
Okay. So it's kind of like a storage, basically an auxiliary memory from which high-speed retrieval is possible.
Oh, okay. Well, that explains it then. Yeah, one of those.
Yeah, but I think if they were trying to define it in terms of internet browsers cache, that's pretty much where they store all the website data from websites that you visit. And they store that data there so that the browser can more quickly open that website again when you visit it again. So it kind of like saves your data from that website.
Cool.
Yeah, and you can always delete it through your browser settings. Yeah.
Cool. Now and you don't have to get too explicit if you know this, because what methods or techniques do hackers employ to break into computers and networks? Is there a typical approach that they might use?
Well, one of the most common is phishing. So look out for phishing, and that's when hackers try to impersonate an authority or a company or somebody you know to get personal information from you that they can just use to log in and access your web services. Okay, so if you suddenly get a strange email from somebody claiming to be from, like, say, your utility company or your internet service provider, and they ask you for a bunch of information, verify that before you answer, because it might be a phisher. It might be a hacker who's trying to phish you.
Great. Then what energy is used for Ethernet? Maybe opposed to satellite or opposite to satellite? Is that something that you had maybe touched on in the presentation?
Let's see. Let me see that question again. Okay.
Yeah. Oh, it's in the main chat. So what
Oh,
energy is used for Ethernet opposite to satellite.
Um,
And I'm not sure if I had missed you touching on that or not, because it didn't seem super familiar to me.
I don't think I covered. I didn't cover that. Maybe they're asking about internet, like satellite internet versus, say,
Oh yeah, maybe internet
fiber
versus like
internet.
yeah. Yeah. If the person that asked that wants to clarify, please do. But yeah, you can't. I think that's a good way to respond. Because there's another question about internet speed. So maybe could you say something about the different levels of speed for the internet? You know, the fiber networks that are now going down in some places, and along those means possibly.
Yeah, okay. So there's a couple levels of internet speed. There's dial-up, which is 56K. Most famously used with like AOL back in the day. Almost very few people use that nowadays. It's much too slow for like modern web browsing, where the websites have like videos and a lot of graphics and sound and all that. And then next there's broadband or DSL. That's faster, and a lot of people in like maybe more suburban or rural places use DSL. But then now there's basically cable or fiber internet, and it's just faster. Like, yeah, it's more suitable for modern browsing. I also do see a question for how can we get affordable internet. Let me put a link from the FCC, the Federal Communications Commission, for their affordable connectivity program into the chat. And that might help everybody find more affordable internet.
Great. And then you mentioned a cookie in one of your answers. What is it and how does it work?
So cookie is basically just a small bit of data that the browser stores when you visit a website. And what it does is it saves your preferences on a website. So for example, let's say you visit Facebook and you log in, then it'll save a cookie to your browser, and it will help you stay logged in if you decide to visit Facebook again in the future. So it's just a small piece of information. However, like, it's good to regularly clear your cache of like cookies and other information, just for security purposes, because it might be utilized by malicious users who might seek to, use those cookies for their own gains. But on its own, it's just a little piece of information that helps streamline your browsing experience.
This question, when, and you might not have an exact date, and that's okay, but when will Web 3.0 replace the Web 2.0?
So it's pretty much a concept that's bandied about. Like these different Web 2.0 didn't suddenly just one day, like boom, like all Web 1.0 websites became extinct, and then everybody is Web 2.0. It's sort of like a gradual evolution that sometimes you might not even see the visual changes. Okay, so from Web 1.0 to 2.0, there's a lot more visual because all the graphics got updated. There's a lot more interactivity on the website. You can see the reviews column, you can write your own reviews. Things are changing, but the transition between Web 2 and Web 3 should be a lot less visually noticeable than between Web 1 and 2, because all the websites look pretty slick and interactive nowadays. So unless they come up with a radical new way of experiencing it, it's not going to be as visually dramatic.
Very good. Now this person asks, going back to the non-fungible tokens, NFTs, how
Okay.
can buying an NFT be worth the investment? And so that might be more of an opinion, but if you have any thoughts on that.
Yeah. So there's basically these reselling websites, these trading platforms for NFTs. So it's kind of like eBay, but for NFTs. You know, you can buy and sell NFTs there, and if somebody's willing to pay more for an NFT than somebody else, then that can be profitable. But yeah, just take that with a grain of salt. They're not regulated, and so there's not a whole lot of regulation around things like cryptocurrency and NFTs currently. So just be careful with those. That's pretty much all I can say. If you find somebody willing to pay more for it, great.
Right. So and then this might also be just based on a specific scenario, but can I use my store-bought router for home internet, or do you have to use the ISP router? And if so, is a router necessary anymore? Sometimes that can be confusing. Yeah, you go and get a couple boxes from the from a Spectrum or whatnot, but yeah, can you use your own?
The answer is that depends on who your ISP is. They have different policies. Some of them require you to use their box. Some of them let you use your own. So it's best to find out what their policy is before going to buy a router.
Great. And here's kind of a overall kind of question here. This person is hoping that we can touch on this as part of the conversation. Can you conceptualize a futuristic world that balances these technological advances, such as the metaverse and Web 3.0, with the need for planet conservation? It's a really great question there about sustainability and you know the use of energy, you know, going forward, because all the faster, you know, faster and more high tech everything gets, yeah, that does use up a lot of energy. Is that something you might have come across in your research or anything about that, Lawrence?
Um,
Yeah, it's kind of a niche question, but yeah, like not to put you on the spot for such as that. I you know I know that that just because of the like the AI and the other talks that I've been doing recently, that yeah, that is a conversation, and it's worth, you know, touching on. I think the you know, different sources of energy, and you know, how are we going to balance that with all the technology that we have now? And I think it's important to be aware of that conversation, even if, you know, we might not have any answers for, you know, I wish I could solve planetary, you know, sustainability in a quick conversation right now, but that's a good question. And it's something that you know deserves to be in the conversation about these kinds of technologies. Um, let me see. I do have some more questions. So we have a question maybe about when talking about privacy protection. You know, could a government or private companies create an ultimate privacy protection for users so we wouldn't have to worry about it? I'm like, that would be great, but I don't know about the logistics of that happening. But it's also another, you know, important conversation to have about you know, government oversight, private company oversight, security. I know Lawrence, you talked a lot about the data issue, you know, having access to all that data and selling it. But the privacy protection route, yeah, I don't know. Do you have any thoughts on that? I don't.
well, I think that while that's a nice idea, it's very unlikely because that would require collaboration between government and big tech to create something that would cut off big tech's cash flow. And I don't see them going for something that'll hurt their bottom line.
Yeah, I have to concur with you there. I think that in an ideal world, maybe that would be something that could happen maybe one day under the right circumstances, but I don't see it happening anytime soon. But interesting concepts, obviously anything that can make the internet and browsing more secure for all is going to be a positive thing. So hopefully we continue in that regard of making things more secure as we can. Here's kind of a this is going back to like blockchain and cryptocurrency. Why does it require so much energy to mine crypto?
Well, so that is a good question. To break it down to very simple terms, each time, like for example, when cryptocurrency is mined, that it's mined by computers having to break down a very difficult math problem, and the difficulty increases with each coin that's mined. So basically, that's why they require more and more computing power in order to mine, for example, Bitcoin. It's part of their built-in system, like it's how it was designed to make it harder to mine as time goes on. And that's just to make the resource more scarce as it was. Yeah. So it's just requiring all this data, all this energy to break down the complex math problem in order to mint a new Bitcoin.
Right, and that's so that it can be as secure, as it is, so that not everybody can just start doing it. It's a lot of processing power. This is also on the topic of cryptocurrency. Is cryptocurrency considered a currency or an asset? I'm just going to wake up my room again real quick.
Okay, so again, there's a lot of different regulation and a lot of different concepts being bandied about by the US government. Let me post a link to the IRS that talks a bit about digital assets and cryptocurrency. That might help, but unfortunately, like they're still debating this. I know like the SEC, the Securities and Exchange Commission, they recently labeled a bunch of crypto as securities instead of like currency, I believe. So it's ongoing at this point. So yeah, just be on the lookout for more changes.
Yeah, nice. And then I think this is kind of harkening back to when we were talking about internet security. Someone asked, is online banking safe?
Again, there's no clear answer. There's no clear-cut answer as to whether or not online banking is safe or not. Again, it depends if somebody has hacked a device or has hacked the bank. It depends on a lot of different factors, but a lot of people regularly use banking on their apps on their phones, and those apps are supposedly encrypted so that the information that passes between your device and the bank it's supposedly more secure. So take that as you will. Connor, do you have
Yeah, it's just right. I mean, relatively speaking, yes. I mean, the banks have high stakes to keep their sites and our usage of their apps as secure as possible. So I would venture to say that yes, it's among the more secure sites online, but like nobody can say with 100% certainty that we're not going to wake up to a big headline about a bank being compromised or hacked or whatnot. So again, just be smart about how you browse the internet. If you're using a public Wi-Fi, be aware of that, and know what kind of public Wi-Fi to trust, versus just some random open Wi-Fi network you found, at a cafe, or that doesn't belong to that cafe. There's just a lot of ways that people will try to break in and do awful things, and you just have to be aware to mitigate those risks as much as you can. But online banking, I've always felt pretty secure about it, but your mileage may vary. So take it like anything else you put out on the internet. Lessen your risks as much as you can. But I think that's kind of near the end. I'm just looking through a lot of the questions got answered with other questions, and I'm not seeing anything else come in. So I think we can go ahead and wrap it up. Again, thank you, Lawrence, for presenting on how the internet works. I'm going to go ahead and put a link to our post-event survey. We really appreciate if you could just take a few minutes to assess how we're doing, what programs are working, topics you might want to see in the future. You can put all your feedback there on that link that I've just placed in the chat. And thank you, everybody, for attending today's event, and have a good afternoon.